All right, guys. So I'm warning you, all right, that these questions are going to get super lengthy, okay? And each of these are going to have multiple parts, all right? So you're going to really want to label your work, okay? And it's just going to take a little bit of time to be able to do this, all right, on your own, okay? But let's just do a quick reminder of what an orthocenter is, all right? So what an orthocenter is it's the point of concurrency or the point of intersection of altitudes, all right? And it's going to be the point of intersection between all three altitudes. But, all right, the way that we're going to do these questions is technically, wouldn't any two of those altitudes, all right, also intersect at that same point? Okay. So that's what we're going to do. What we're going to do is we're going to find the equation of two altitudes, and then we're going to find the point of intersection, all right, between those two lines. All right. Now, before we start, I'm going to do just a quick recap. All right. And I'm going to just scooch down here real quick. All right. About something I went over in chapter 3, which is special cases. All right. And you can just pay attention here. So, with special cases, what I'm talking about are vertical and horizontal lines. And what I did was I gave you guys this mnemonic device, which is going to be VUX HOI. And you're going to use this quite a bit here. Okay, so I just want to make sure that you guys are getting this so that you know what I'm talking about. Okay, so for VUX, what it's talking about is all the vertical lines. All right, and vertical lines have undefined slopes. But what's going to be really helpful here today is that the equations of these vertical lines is going to start with x equals. So it's going to be like x equals a number. So for example, like x equals 5, x equals 1, all right? And what that means is if you just had a quick coordinate plane, all right, and you had just a straight line like this, okay, and let's say it's going through 2, right? This would be a vertical line. The slope of that line would be undefined, but the equation of that line would be x equals 2, okay? Now, the next one is HOI, which means you have a horizontal line, all right? It has a 0 slope, and the equation of that is going to be y is equal to, and it's just going to be y is equal to a number, okay? So another example, once again, if I drew my coordinate plane, all right, if you had a horizontal line like this, okay, and this time, this is a horizontal line, it has a 0 slope, but the equation of that is going to be y is equal to -2. Okay, no x's in there, just y is equal to -2. All right, so I'm going to be using this quite a bit because you actually want to get to the special cases, all right, because it's going to make the questions a lot easier, okay? So I'm going to scooch back up here, and I'm going to go back up to number 6, okay, because it's asking us to find the orthocenter, and the orthocenter is the point of intersection between any 2 or 3 altitudes, okay, in the same triangle. So what you're going to have to do is you're going to have to pick, all right, which one you want it to come from. And you can pick any 2 of the 3, okay? So what I'm going to do is I'm actually going to start with J, all right? So I'm going to go from J. All right. Now, one of these questions might take like 7 to 10 minutes, okay? Because you're writing the altitudes of 2 lines and then finding the point of intersection, okay? So if I'm trying to write the altitude from J, all right, it is the perpendicular segment that connects J to the opposite side, and the opposite side is going to be KL, all right? So to do that, to write the altitude, the first step is you're going to find the slope of KL so that we can do the perpendicular slope to it, okay? So the slope of KL is going to be -2 minus 6, all right, all over 9 minus 5. All right, which means that I get -8 over 4, which means my slope is -2, okay? But I don't want that slope. I want my perpendicular slope. So my perpendicular slope is 1/2. And I now need to write my equation, all right? And once again, my equation is going to contain that perpendicular slope and the point that it's telling you to pass through, which is vertex J. Okay. So to do that, I'm going to put it into point slope form. All right. So I'm going to do y minus negative 2. So y plus 2 is equal to, and you're going to get 1 half times x minus 3. Okay. So I'm obviously running out of room here, guys. All right. So what I'm going to do is I'm going to bring this up, take this up here. Okay. And I am going to find the equation of that line. Okay. So I'm going to multiply everything by 2 so I don't have to deal with fractions. All right. And if I multiply this by 2, it cancels it out. But I also have to multiply this side by 2 and this side by 2. So I'm going to get 2y plus 4 equals, and I'm going to distribute that 1 through. So 1x minus 3. Okay. I'm going to bring my 4 over. So I'm going to get 2y is equal to 1x minus 7, which means that when I divide by the 2, I get y is equal to 1 half x minus 7 halves. Okay. So that's my first equation. That's only one step in all of this. Okay. So that's just one step right there. I now need to find the altitude from another point, and I'm going to choose K. All right. So I'm going to choose K. All right. Which means that if I'm coming from K, it has to intersect the opposite side, which is going to be JL. All right. So my first step here is I'm going to find the slope of JL. Okay. And so when I do that, I'm going to get negative 2 plus a positive 2, all right, because it's negative 2 minus a negative 2, okay, all over 9 minus 3, which gives me 0 over 6, which gives me a slope of 0, okay? But I don't want that slope of 0. What I want, all right, is the perpendicular slope to 0, right? So my perpendicular slope to 0 is actually undefined, okay? But once again, guys, we're dealing with special cases. So I'm going to talk about Vux-Hoy, all right? So what I want is an undefined slope, which means that my equation is x equals, right? So if you look at what it has to pass through, it has to pass through K. All right, what is your x value of K? It's 5. So my equation for this is x is equal to 5. And that's my second step. Okay, we talked about that in chapter 3. Okay, so the reason why we want these special cases is it actually makes our point of intersection step a lot easier. Because when we talked about point of intersections before, what we did was we did systems of equations where you had to set the two equations equal to one another. Okay, this is going to be easier because you actually already have what one of your values is equal to. So we're going to use substitution again, all right, but it's going to be a quicker process. So my last step is I'm going to find the point of intersection, all right? Whoopsie. All right, the point of intersection. And what I'm going to do is I'm going to use my two equations from those first two steps, okay? And I'm going to take that x and plug it back in to the j. All right, so what I'm using, all right, is one more time, all right, my equations from the first section, and I'm going to use my equation from the second section, and I'm going to now take that 5, all right, and plug it in for that x right there. So what I'm going to get is 1 half times 5 minus 7 halves, all right. Solving that, I'm going to get y is equal to 5 halves minus 7 halves. All right, which means using your fraction properties, you're going to get negative 2 over 2, which means your y value is negative 1. All right, which means that your orthocenter is 5 comma negative 1. And that's your final answer. Okay, I'm going to do one more, all right, right below it in the next video.